All right, so this should be review. So go ahead and pause the video, try these two problems, make this one a subtraction and this one addition if it doesn't show up on your paper. All right, and then go ahead and try it yourself. All right, if I find the measure of ABC is 98 degrees, what is the measurement of angle ABD? So I know that all I have to do, since ABC is my whole angle, these two are angles that make up that whole angle, I should add these together and set it equal to 98 degrees. So we got 6x plus 14 plus 3x plus 29 is equal to 98, okay? Then I'm gonna combine my like terms. So this is 9x right here plus carry over. So that's 43. Yeah, 43. All right, I tried to do it in my head. And then, so I'm gonna subtract the 43 on either side. I get 9x is equal to 54? No, 55. 55, I think. Yeah, let me make sure I subtracted right, because I don't wanna, or added right. Yeah, 43. Yeah, 55. All right, I should have been just confident. And then I'll divide by 9. And x is about 6.1. Okay, and it says find the measurement of ABD. So ABD is this one. So I'm just gonna plug that 6.1 back in. 6.1 times 6. So we're plugging it in. So 6 times 6.1 plus 14. I'm sorry, I did not give y'all enough room. Then plus 14. All right, it says about 50.6 is our answer. All right. Then over here is a straight angle, so we know that this is 180 degrees. So I'm going to add these two angles together and set them equal to 180. So I'll combine, this is 14x minus 2 is equal to 180. Add the 2, 14x is equal to 180. Divide by 14, we get x is equal to whatever 180 divided by 14 is. Yep, which is 12.86. All right, so to find KLN, I'm gonna plug it back in. So 10 times 12.86 minus 5. And that gives me 123.57. All right, so it's all right to get decimals, y'all. Don't be freaked out by those decimals. Okay, so here's what we're going to be talking about today. We're going to be talking about angles and triangles, okay, and how we name triangles. So go ahead. What I would try to have you guys do is I would let you guys try and name all of these over here with these, with these triangles. So I might go ahead and label this one A, B, C, D, E, F, and then G. Okay, and some of these labels might go with more than one thing, so just try your best. All right, so let's go with the easy ones. I'm gonna first start with A. We know A is equal angular, right? Because it's telling me all these angles are equal. Okay, so I'm gonna put A over here. And then this one right here that has all of our sides that are congruent, this is equilateral. Okay? Then we have a right angle over here, so this is going to be a right triangle. Over here we have two sides that are equal. So if we have two sides that are equal like that, then that is called an isosceles triangle. So we're going to put that D over here. E we consider an acute triangle, okay? Because all of our angles are small. And then our scalene triangle is just all of our sides and angles are not equal. So F over here. And then an obtuse angle, you see this one right here, or triangle, this angle right here is greater than 90 degrees, so that is our obtuse angle. All right, so just kind of review some of the names. So when I'm saying, oh, this is equilateral or equiangular, you know what I'm talking about. All right, so right here for this first one, perfect example, because we have equal sides and equal angles, this is called an equilateral. Triangle. And it could be a equiangular as well. We'll just refer to equal lateral more often in geometry. Over here, since this has an angle that is greater than 90 degrees, we're going to call this an obtuse triangle. Over here, we look at all of our angles. Since all of our angles are less than 90 degrees, we're going to call this an acute triangle. It can also be the same thing like this one. Like, we can go ahead and write equiangular as well. Oops. Equiangular. Sorry. An acute, but this can also be considered scalene because all the angles are different and all the sides. So scalene triangle. All right, then same thing over here. All right, we can see that both of two sides are equal and two angles are equal. So this is an isosceles. Triangle. All right. So our triangle sum theorem says the sum of three angles in triangles always equal to 180 degrees. So this is an example. If we're given a right angle, we're given one other angle, then we can find what the missing angle is by doing 180 minus 90 minus 38. And that'll give me my my angle there. So 180 minus 90 minus 38. And that gives me 52. So measure of angle 1 is 52 degrees. All right, so what I would have you do is pause the video and try finding all the missing angles here. All right, so what I do for this first one is I'm gonna do the same thing for actually all of them. So 180 minus 78 minus 31. And so 180 minus 78 minus 31 gives me 71. Okay, here we do the same thing. 180 minus 40 minus 30, that gives me 110. Same thing, 180 minus 90 minus 38. I think that one was similar to the one we did on the first page, but let's see. 180 minus 90 minus 38 gives me 52. All right, and then here we do 180 minus 60 minus 60, which is equal to, let's do 180 minus, okay, 60. Oh, that's cool. This is an equiangular. All right, so that's pretty much it. So with your triangle rules, all of your angles are equal to 180. So you can just do that. The measure of an exterior angle, so this is a very important theorem right here. Exterior angle theorem says the measure of an exterior angle of the triangle is equal to the sum of the two non-adjacent interior angles. So this makes sense, right? If we relate that the inside of a triangle is equal to 180 and this line right here is equal to 180, the leftover, these two, from this triangle should equal this outside distance, okay? You don't have to know all that, but if your mind thinks that way, okay, it makes sense that these two, relating those two things, the line being 180 and this triangle equal 180, that these two angles should equal this outside angle. So we do x plus 70, right? The inside, non-adjacent, so one is not attached to this line, equals this outside angle, 2x minus 5. All right, and so we'll just subtract the x, add the 5, and we get 75 is equal to x, and we're done. Okay, that's what it's asked for. Didn't really say what it's asking for, but always check and make sure, okay, did it ask for x? In this case, I'll be like, yeah, I guess they're just asking for x because they're not asking for a specific angle. Okay, but always make sure. All right, same thing, we'll add these two on the inside, 2x plus 65. And we'll set that equal to 3x plus 25. Oops. Okay. I'll subtract the 2x. Subtract the 25. We get 40 is equal to x. We're done. All right, so if I went too fast, feel free to pause it, go back if you need to. If you feel good, go ahead and solve for x for these 4, and we will be done. All right, go ahead and pause the video. Hopefully you're done. I'm about to go over the answers. All right, so we do 2x plus 12 plus 5x plus 11 is equal to 72. All right, these two add together equal that one. We'll combine like terms so we get 7x plus 23 is equal to 72. Subtract the 23. 7x is equal to 72 minus equals 49. 5 by 7. X is equal to 7. All right. Moving on to number 2. We get 13x plus 1 is plus 32 is equal to 24x. We were going to add these. 13x plus 33 is equal to 24x. Subtract 13x. 33 is equal to 11x. Divide by 11. 3 is equal to x. All right, same thing here. Hopefully you're getting 100% so far. When you tried it on your own, add these two, set equal to the one on the outside. X, oh man, I should have just added those together. Oh well. So these are 27. Oops. Add the 1, 27x is equal to 81. X is equal to, I think there's 3, but I'm gonna make sure. Yeah, 3. All right, last one. 10x plus 56 should equal 23x plus 4. We're gonna subtract 10x, subtract 4. 52 is equal to 13. Yeah, x divided by 13. X is equal to 4. And we're done. All right, if you have any questions, feel free to reach out. Again, if it went too fast, feel free to rewind the video. But good luck, do great. I believe in you. See you soon. Bye.